All right, and welcome to Graphing Linear Inequalities, Level 3. Now here, notice that I'm actually giving you all two inequalities, and whenever we have two or more equations or two or more inequalities, we actually call this a system. So here we'd say this is a system of inequalities. Now the only way that you can solve a system of inequalities is by graphing. It's really literally about the only way. So let's go ahead and tackle this, and let's kind of start off with our big graph over here, and we'll just kind of add to this graph as we go along. And let's start out with our inequality that's in slope-intercept form. So I see here that the y is by itself, and I say, you know what, I can actually go ahead and I can graph that. Alright, so my y-intercept is positive 3, we go up 1, 2, 3, put our very first point. We see that our slope here is 2 over 3, so we can count up 1, 2 to the right, 1, 2, 3, put our point. And notice that this is the less than symbol, so it must be a dashed line. And it looks like we're going to just kind of lightly shade everything below. Alright, let's go on to our next one. Now notice here, what we want to do is we want to put a little star by the 4, and ask ourselves, is the coefficient in front of y positive or negative? In this case, it's positive, so we know that our inequality will actually stay the same. Very helpful to always make that little note. Well, we want to get y by itself, so we start by subtracting our 2x from both sides. This is a 0 pair. And now we can say, okay, well, we have this. We get the right color here. We have 4y is greater than. And if I were to ask you, what is negative 8 minus 2x? Well, hopefully you would say negative 8 minus 2x. They're not like terms, they can't combine. And then from here, we know we can go ahead and divide everything by 4. Alright, and at this point, we know that because of our little note right here, our inequality stays the same. Negative 8 divided by 4 is actually negative 2. And negative 2 over 4 reduces to negative 1 over 2x because we can divide both of these by 2. Now let's go ahead and graph in our nice pretty green. We see that our y-intercept is negative 2, down 1, 2. And let's see, our slope is negative 1 over 2, so we're going to go down 1 and to the right 2. And we can go down 1 and to the right 2 again. Okay? And then from here, the question becomes, well, should this be a dashed or solid line? It is a greater than symbol, no equal to, so we can go ahead and do that. And since it's greater than, we know we're going to be shading everything above that line. And you'll notice that we actually have a double shaded region. Now, I want to switch colors here, and I really want to emphasize the double shaded region. Like looking on this, can you see where both of our green and our orange shading overlap? And they're really kind of overlapping here in this region to the right. And it's actually here that we'd find all of our solutions to the inequalities. Okay? If we went over here where it's completely unshaded, we'd say there's no solutions whatsoever. If we went up here to where it's just shaded in the green, we'd say, well, those are solutions to the second line. If we went down here where it's just shaded only in the orange, those are the solutions to the first line. But where we find the solutions to both inequalities are going to be over here to the right in this double shaded or now purple shaded region. Now let's do a second example. Okay, here we have example 2, and we have y is greater than or equal to 1 over 4x. Okay, let's just go ahead and graph that. That's pretty easy. We see that there's nothing being added over here to the right. That's like saying plus 0. So we can cross at our origin, and our slope is 1 over 4, so we can count up 1 and to the right 1, 2, 3, 4, and put our first point, or second point I should say. Now from here, the symbol is greater than or equal to, so now I'm going to use a solid line, and I'm actually going to wind up shading everything above. Now let's go ahead and switch over to my purple color here, and we want to go ahead and solve this inequality, the second one, for our letter y. So we can subtract 2x from both sides. We have created our 0 pair. Now we have negative 8y is greater than 16 minus 2x, which is 16 minus 2x. And by the way, I should have done this earlier. We should have looked in front of the y and said, hey, is our coefficient positive or negative? Here, I notice it's negative, so I want to put a little star, and I want to say the word switch or reverse. So we know that on this very next line, when we divide everything by negative 8, we know that our inequality is going to reverse or flip. And so what can we say? Well, we can say, all right, we have y, and when our greater than symbol switches, it goes from greater than to less than, and 16 divided by negative 8 is negative 2, and a negative divided by negative is a positive, and 2 and 8 can both be divided by 2, so we actually get positive 1 over 4x. Now from here, this is actually kind of interesting. So our y-intercept is negative 2. We'll count down 1, 2, put our point. But our slope is actually the same as our first inequality, positive 1 over 4. So we can count up 1 and to the right 4. And here, because it's a less than symbol, I know it's going to be a dashed line. And less than means we're going to shade below. And I want to ask you, do our shaded regions ever overlap? No, they don't, because we have the same slope. These two lines are parallel, as we kind of discussed in our level 4 video from the last series. And since they're parallel and the shadings don't overlap, we'd actually say that this graph has no solution. There's no region ever where our shadings overlap, so there are no solutions. All right, thank you so much, and I'll catch you in our next level.